Hello everyone, and welcome back to Revit Snippets. Great tips you can learn in just a few minutes.
This video is sponsored by Tagitize, the easiest way to run Tag All on multiple Revit views and sheets. Also, say goodbye to overlapping tags. Tagitize will turn this into this. Try Tagitize completely for free using the link in this video's description. Have you ever wanted to automate your grid annotation in Revit? For example, telling the grid bubbles to appear consistently along one more side of your plan view? How about generating dimensions for your grids as well? These are all very simple things to do manually, but when you're in a big Revit model with hundreds of views, all showing multiple grid lines, this will take lots of time to do manually. So let me show you today how to quickly automate grid dimensions in your Revit view. Here's how the finished script will look like. With this, you can select any number of parallel grid lines, click Run, and voila, a new dimension for all those grids has been generated. We can then move it to the desired location, and then repeat this process just one more time for the secondary grid direction. The goal is to do something similar to what Tagitize can do here, but without using the plugin. Instead, we only need Dynamo and a few minutes to create a super simple script that does the same thing. In the upcoming videos, I will also show you how to replicate other advanced grid dimensioning features. For example, turning all grid bubbles on or off at once, or generating grid dimensions in multiple views at the same time, like what we're seeing here. Or placing new grid dimensions at an offset distance away from the grid bubbles. With these advanced features, we can finish creating grid dimensions for any number of views in just a few seconds. These include both primary and secondary grid dimensions, as I'm showing here. If you want to see how to automate these advanced features, make sure to subscribe now to see the new videos as soon as they drop. Now, let's proceed to Dynamo.
If you don't have much time and just want to run this script right away, simply find in the video's description a link to download this script directly. If you, however, want to learn to code this yourself, let me show you how right now, step by step.
To start, let's create a new script in Dynamo. I will change the run mode from automatic to manual so it won't hang on us unexpectedly. The first thing to do now is to add a node so we can select our grid lines. This one will do. Let's select these grids here as an example. I will now add a Python node to the graph and open it for editing. However, this is not a good script editor, so I'll type the code out in Visual Studio Code instead and copy it back into Dynamo at the end. If you're new to this workflow, don't worry. Just find in the video's description below a link to my other tutorial on how to set up this coding environment. It will also provide you with this Python template for Dynamo that will give you all the necessary information to then return to this video and start scripting with me. We'll start by getting the input coming from Dynamo. At this point, the user has selected a set of grid lines in Revit, and Dynamo passes those into this Python node. The first thing we do is unwrap those elements, because Dynamo wraps Revit elements by default, and we need the native Revit API objects to work with them properly. We're also assuming that the selected grids are parallel, because the logic that follows relies on that. Next, we grab the currently active view from the Revit document. This is important because grid curves can vary depending on the view, and dimensions can only be created in the context of a specific view. Everything we generate later will live in this active view. Before doing any real work, we add a safety check. If fewer than 2 grids are selected, there's nothing meaningful to dimension. In that case, we immediately exit the script and return a clear error message explaining how many grids were found and that at least 2 are required. This helps avoid confusing failures later on. Assuming we do have enough grids, we move on to preparing the dimension settings. First, we retrieve Revit's default linear dimension type. This keeps the script flexible because it will automatically use whatever dimension style is set as default in the current project instead of hard coding a specific type. Now we collect the actual grid geometry. For each selected grid, we retrieve its curve as it appears in the active view. Grids can have different extents depending on the view, so we specifically request the view-specific curve. We store both the grid element and its curve together because we'll need the grid for references and the curve for geometric calculations. Once we have the curves, we determine the direction of the grids. We take the first grid's curve, extract its start and end points, and calculate a normalized direction vector between them. This gives us a clean unit length vector representing the direction the grids run in space. With that direction known, we compute a perpendicular direction for the dimension line. Since dimensions need to run across the grids rather than along them, we rotate the direction 90 degrees in the XY plane. This gives us a vector that points outward from the grids, which is exactly what we need for placing the dimension line. Next, we decide where the dimension line should start. To keep things simple and robust, we use the midpoint of the first grid curve. This ensures the dimension line is placed roughly centered on the grid extents, regardless of how long or short the grids are. Using that midpoint and the perpendicular direction, we create a short construction line that will serve as a dimension line. We don't need an exact length here, just something long enough to host a dimension. Revit will take care of extending it visually as needed. Now we prepare the references for the dimension itself. We create a reference array, then loop through each grid and append a reference to it. These references tell Revit exactly which elements the dimension should measure between. At this point, everything is ready, so we start a Revit transaction. Anytime we create or modify elements in Revit, it must happen inside an active transaction. We then attempt to create a dimension using the active view, the dimension line, the reference array, and the chosen dimension type. We wrap this step in the try except block. Dimension creation can fail for several reasons, such as invalid geometry or incompatible views. So if something goes wrong, we capture the error and pass a helpful message back to Dynamo. After that, we cleanly end the transaction. Finally, we check whether the dimension was created successfully. If it was, we output the new dimension back to Dynamo so it can be previewed or used downstream. If not, and no error was already reported, we return a final fallback message indicating that the dimension creation failed. And that's the complete workflow. Next, let's copy all text from this file, paste it into the Python node in Dynamo, save it, and close this node. With that, our Dynamo script is finally complete. Let's now run the script to see it in action. There's also a link in the description to download the script we built together today. Before you go, check out our sponsor, Targetize. With Targetize, it's never been easier to tag multiple Revit categories at once using your favorite tagging styles. Say goodbye to spending countless hours untangling Revit tags. After running Targetize on this view, for example, all my tags are perfectly readable. None of them overlaps with their hosts or other elements in the view. If I think this tag, for example, can be placed better, I can just select it and click Next to tell Targetize to try the next possible tag position. Each time I click the button, Targetize moves the tag for me, and I can keep doing this until it gets to a tag position I like. There we go. That's much better. Try Targetize completely for free today using the link in this video's description. Even more, if you want to master Python scripting in Dynamo to create this kind of script yourself, check out my full online Python for Dynamo course, also linked to in the video description.
If you like this lesson and want more like this every single week, make sure to subscribe to this channel now. For now, have a good day and I'll see you in the next tutorial.